So let's draw shear force and bend moment diagram for this beam, right? First, we said when it comes to drawing out your shear force and bend moment diagram, your very first task is to find what your reaction, please. That's first priority. So let's look for reaction, please. First task. Before then, you have to draw out your what figure diagram, right? So a diagram that shows the forces acting a structure. This is a phase support, Abby, and this is a what roller support, Abby. So I'll just change them, and this becomes what? This is a phase support becomes what? In this way, Abby. Yeah. It says active reaction, Abby, yes. But I'll forgo what the horizontal because it's always zero. Yeah. So I'll have what R A Y here, Abby. And because what there? R what? R B Y. So your first task to draw a figure diagram, which I've done this way. Next one is what? Calculate for what? Your reaction. So calculate for reaction. Yes. Calculating for reactions. Please, my first task when it comes to calculate for reaction, what condition am I applying there? The condition of what? Equilibrium, Abby. That's what? Summation H equal to what? 0. Summation V equal to what? Moment at a point equal to what there? 0. So by the way, we said we are not using this one here because it's always 0. So let's focus on what? These two. First task, summation V equal to what? 0, B. Consider up as what? Plus, down as what? Negative. In this structure, which force is acting in this form? How many are there? 1, 2, 3, 4, B. So this becomes what? RAY as acting upward plus sign plus what? RBY next up minus 20 minus what? 20 equal to what? 0. Minus 20 minus 20 is what? Minus 40. So I'll have RAY plus RBY minus what there? 40 equal to what? 0. Take this 40 here. I'll have RAY plus RBY equal to what there? 40 kilo newton. Take it as what? Your equation 1. I've applied this one successfully, Abby. What's next now? Moment, Abby. So taking that at what? At point A. So taking moment at what? At point A. At point A. So that becomes what there? Summation MA equal to what? 0. Consider what? Your clockwise as what? Anti as what? So what do I get there, please? If I don't want at A, it means this one is there, Abby. So this man, this and this will move down to A. So this one move what? In this direction, Abby. Because of the A clockwise, it becomes 20 times what? 2. So I have 20 times 2. I'm done with this first one. Next up, this one move what? In the clockwise too, Abby. To where? This part, Abby. So this here is what? 5. That becomes what there? Plus into 20 times 5 plus into what next there? This one, Abby. Move this way. In a what? Negative direction, Abby. Becomes what? A negative what? RBY times what? From here to here is what? 7. So I have this. Are you sure? Alright, for me now, what I get here, this is now equal to 40. Sorry. We said it's always what? Equal to 0. So equal to what? 0. Alright, 40 plus what? 100 minus what? 7 RBY equal to what? 0. Take this young man here. So I'll have what? 140 equal to what? 7 RBY. Let's get RBY. Divided by what? 7 by what there? 7. What do I have here? So therefore, RBY is what there? 20. So 20 what there? Kilo Newton as my RB. So let's get what? RA from what? Equation 1. From here, from equation 1 that says what? RAY plus RBY equal to what? 40. True. All right. Put the value of RB as 20 here. So have RAY plus what's RB? 20 equal to what there? 40. Take this one here. So have RAY equal to 40 minus 20. So what's RAY there? RAY is equal to what? 20 kilonewton. First task in shear force and moment. Get your reaction. So my RAY is 20 and my RBY is 20. Of course, if I should add this 20 plus 20, I'll have what there? 40. Similarly, add 20 plus 20, I'll have 40. Makes sense, please. Copy this down, please, and let's proceed. So when it comes to shear force and measurement diagram, your first task is to what? Draw a figure diagram. When you are done, what next there? Calculate for the action. But when it comes to a reaction, you ignore what? The first condition. That's what function H, because it's always equal to 0. So that's the task there. Start from function V and moment at the point. So I have this place. Alright, so we are getting the value of RA. Hold on. What's RA now? That's 10 kilonewton. What's RB? Also 10. Is it 10? Sorry, 20 per se. 20 kilonewton. RA is 20, please. 20 kilonewton. I want the two values now. So let's proceed, please. Copy down and let's proceed. So let's proceed, please. From here now, let me just rub this part away. So let's now do shear force and bending moment calculation. So first priority, whenever you see a question, draw out your figure diagram. When you're done, what next there? Calculate for reaction. Next task, move to what you are asked to do now, which is what? Shear force and bending moment calculation. So all right, from here now, let's start with shear force, please. Shear force calculation. Right, let's start with it, please. Shear force calculation, please. So I'll give you key concept to note, and then you're good to go, please. I'll give you key concept to note, and then we are done, please. All right. Look up for shear force. Look up, please. For shear force is in two conditions. Either I choose to go with left hand side reading or right hand side. Listen, for shear force there is in two ways. Either I choose to go with what? My left hand side reading or my right hand side reading. What do I mean in essence? It means that if I'm going to with left hand side, I should expect that upward is what? Positive, down is what? If I'm going to the right, because what the up is what? Negative, down is what? Please. So I always advise to go with what? Left hand side, because why? You are familiar with what? Up being positive, down being what? The negative. So we are doing shear calculation. Specify which direction you are following. Is it left or right? If it's left, I expect that up should what? Positive, down should what? Negative. Please note this thing. Your first task to note when it comes to shear force calculation, please. I haven't noted this. I haven't noted this. Next task is that how many sections do I have here? Please, I have section A, B, then it comes with the C and D. So when it comes to the calculation of shape and bending moment, you have to name each forces. So this force A, yes B, then becomes C and D. Right? That's the concept. So after understanding this concept, next task you have labeled your each force. Next task now is that I'll pick each force in this format. Look up. Start with this one. No, it's meant to be A, B, C, D. But what I'm seeing is A. After it was like there, C. After it was like there, D and B. So that becomes what? A first. What next? C. What next? D. What next there? And B. So I have this. So this is the first thing I say you should note, Abby. Second thing to note is that shear force starts with a number and end with 0, please. Number two. Note that shear force starts with a number and end with 0. Number one is that if you're taking your readings, we observe you're taking reading form. Is it left or right? If it's left, I'll give the condition. If it's right, I'll give the condition. Abi. Second thing to note is that shear force starts with a number and always end with what? Yeah. 0, please. So if you're doing a shear calculation and your answer starts with a number and does not end with 0, it is wrong. So shear force starts with a what? A value and always what? End with what? End with 0, please. So we're going to go with these two things now. We're going to go. First is first, when it comes to shear force, observe, are you doing left or right? So we're going with what? Left. Why? Because we're familiar with upward as positive, down as what? Negative. After that, identify your forces A, B, C, D in this format, not A, B. In what you are seeing here, I'm saying A before C, before D, before B. So in that format, when you are done now, look up. We said this is called shear force, Abi. Now, if I come to this section here, if I share this section this way, what I'm seeing now is what I'm seeing here, Abi. What I'm seeing, I'm not going for left hand side, Abi. I'm not going from right hand side like this. It's from left. So if I share this place, what I'm expecting is this. I can't see this. These are right. I can't see them at all. So if I share this place now, I can only see this part here. Please, this man, is it going up or down? Up, Abi. For up, what do I have there? So I have what there? Positive what there? 20 what? 20 kilonewton, please. First tax. This part here, I've shared this part, Abi, is going upward. So become what a 20 kilonewton. Now here's the concept. For shear force calculation, the first thing to note is your direction, Abi. Second to note that it starts with what? A value and what? End with what? 0. Third thing to note is that whatever you have as your first reading here, repeat it down first before you consider what? That section. So put 20 down here. I see that. Now let's consider C itself now. For C, please check C. If I should share C this way, this line is going up or down? Down. Down, Abi. Down is what there? Negative. So what there? A minus what? 20 what? Right? Yes. So all my answer here, this is 0, Abi. Please, by the way, there's nothing like 0 kilonewton. Is 0 is 0, not 0 kilonewton. What are 0? What are kilonewtons? So it's wrong, place. Just ordinary 0. All right. We said after getting answer for any heavy forces, repeat that answer down. When I got this one has 20 kilonewton, what I do there? I repeat the answer down first before considering what? C. Now I want to consider D. Now what I do first? I will repeat this answer down first before considering what? D. So put 0 down first. Now at D now, if I should share this D, what is going there? Downwards. Abi, because of a negative, that becomes what the minus 20. What's the answer here? Minus 20. Abi? Yes. By the way, I said shear force starts with a number and end with 0. Let's say this will end with 0. Now, what's the next thing there? We said repeat your what? Answer down first because you consider what? That section, Abi. That becomes what the minus 20. Consider your B. This one is up and down. Up, Abi. What was the A plus what? Plus 20. What's the answer there? 0. That's it here. That's all. So shear force starts with a number and always end with what? 0. First tax. Share your A. For this part here, at A, this one is going upward, Abi. You got 20 kilonewton here. Before you consider any section for shear force, repeat what you're having down here first before considering any other sections. So I repeat this one down first. After repeating down, what is C? This is C. Going up or down, downward becomes a negative. That becomes minus 20. This gives 0. Repeat this 0 down first because you considering what? D. Now at D, this is going what? Downward. So you become the negative 20. So I have my 20 minus 20 here. Finally, I have what there? Finally, can you repeat this minus 20 here, Abi? And then what's next there? Plus what? This one is going upward. Going a plus sign. Plus 20 equals 0. This one. So pick an example that I used. Like I'll try to pick an example that the man used in class. And then look at it. D prime. No, this is good. Those are just stress. It's trying to look for other methods. There's a different way of doing it. So I'm just trying to take my time to give you the easiest way. Yes, easiest, fastest way and go. That's shear for this. That's all. That's all. Yes, that's all, please. Let's not do with the same procedure. Let's do it. We'll do it. Don't worry. We'll do it. It's time for mental space. Let's all right. Can this part? Yes. Let's do bending moment calculation. We're done with shear force. Let's do So similarly, if you choose to go with right hand side too, you still have the same answer, right? Because left hand side, this one is going upward, positive 20, downward. You have to keep that 20 down, for forward, downward, minus 20. See the same concept, please. Let's do bending moment calculation. Let's do bending moment calculation, please. The same concept works. That has your sections. I have section what? A, C, B, and D. I have A, right? What there? I have C. What again? I have D. And I have what? I have B. Those are the first thing you write out first. Now listen. Things to note for this one, please. For SHEAR force, I gave you 3 things to note, Abby. For SHEAR force, the readings left and right. I gave you, it starts with a number, end with 0. I said whenever, and the third thing I gave you that whenever you write anything here, repeat down first before continuing on that section, Abby. Now for bending moment, what are the things to note, please? Please. First to note on that bending moment is that bending moment starts with 0 and always end with 0. Bending moment starts with 0 and always end with what? Always end with 0. Bending moment starts with what? 0 and always end with 0. Are we there? Are we together? Yeah. Now, similarly for your readings too, it goes similar to that SHEAR force calculation reading. If you're taking left hand side reading, are we there? Your clockwise is what? Positive. Anti is what? Negative. If it's right hand side, it becomes what there? Clockwise is what? Negative. If it becomes what there? Positive. Like they reverse the case. Similar to that other concept, please.
Always start with 0.
Yes, that's number 1. Number 2 is that for left hand side reading, clockwise positive, anti is what? Negative. If it's right hand side, clockwise is what? Negative, anti is what there? Positive. That's the concept, please. So I've noted this, please. SHEAR force at, look up, please. Look up. If I take note at A is what? 0. Abby? So I feel I'm having what here? 0 here. Please do not repeat. It's for only SHEAR that you'll be repeating concept. Here, do not repeat. Are you there? Now look up. Oh. We are taking from what? Left hand side, Abby. So here we'll consider what? Left hand side here, Abby. Yes, we consider what there? A left hand side concept, Abby. Now please, to go my left hand side, look up. If I take a moment at A, if there was a force here, what do I expect? This force to come to A. Yeah. Abby? Because by the moment that as if they are fighting somewhere, and they are fighting, everybody wants to look at that particular place. So I'm taking my reading from left hand side, Abby. Now, if I take one at this point now, is 0 already. Yes. If there was a force in this left hand side, that force will have what? Come down to A.
0.
Are you there? Yes. So, but nothing was here. There's nothing here. So that becomes 0, Abby. Now at C now, let's look at C. C is 0 too. Yes. So it becomes what? 0. But I'm moving what? Left hand side. There's something here. There's a force here. 20, Abby. This will now come to C. Are we there?
Yes.
20 will now come to C. Yeah. It was a left hand side reading, Abby.
Yes.
So at A, when that A is 0, so I'll put 0 there because there's no force here again. Nothing is there that can come to A. Are we there? Yes. I'm not seeing all this one again. Yes. Because I'm coming from left hand side. What I'm seeing is just blank here. Yes. This is right hand side now. Yes. So left hand side, if I take a look at this point here, it's 0 already. There's no force acting here that can come to A. Are we there? Yes. Because that moment is put and distance. Yes. So there's no force here. And there's no distance that can come to. Yes. So A now is 0. I'm done with A. So what to see now? A now I can now see A, but I'm not to see now. Focus on C. Focus on C is what? 0, Abby. But I can see this A. So this A will now go to C this way. What's the force here? 20. This is what?
Yes.
A what? A clockwise, Abby?
Yes.
Let's look what there. Plus, what's the force there? 20 times. What is times there? 2. So I have this. Are we there?
Yes.
Outside this A, isn't that force that can come to C? No. So what's my answer here? That's 40 kilonewton. I'm done with this. Go to D. Look up. Clean this one. Go to D. At D is still 0, Abby. But what can I see? these two force, look up, these two will now come down to B, to D. So this one will come this way, Abi. This way. This one go what? This way, Abi. This is what? 20 times what? Times 5. 20 times 5 plus into, this one is what? A negative. Anti-clockwise, Abi. To D, anti-clockwise manner. That will come out there. Minus 20 times what? 3. Please, if I take one at D, outside these two, is there another force here? This just is 2, Abi. So I've considered 2 forces. So what's my answer here? This is what? 100, Abi. This is what? 60. Abi? This is 60 now. Yes. So 100 minus 60 is what? 40. So I have 40 here. Kilo Newton, Abi. Finally, at B, I expect that A is 0, B should what? 0, Abi. Now at B, take note at B. Look at B. B is 0, Abi. That becomes 0. But by the way, 1, 2, 3 will go to B. True? Yes. So if this one go to B, so 20 times what? 7. That becomes 20 times 7. Observe, we must have 0 plus into. So what is on it? Minus what? 20 times what? 5. Minus 20 times 5 plus into. This D come because there. 20 times what? 20 times 2. True? Yes. What I have here? 140, Abi. Huh? Yes. Okay. Minus 100 plus what? 40, Abi. What's my answer there? Hold on. 140 is what? 40. 40, Abi. No, there's a mistake somewhere. This is just 45. I'm to have 0 as my answer. Hold on. Hold on. If you are saying yeah was negative, yet it was there to be negative. So we don't put negative sign. Negative sign. Right? Negative sign. So here's what? Minus 2. So now from here, 140 minus 100 is what? 40. So I have 40 minus what? This 40 here. That's what? 0. So chef, very much start with 0 and end with 0, please. And now, oh yeah, let's go. Let's look at this. Now, after you're done with your calculation for shift and better moment, next task is what? The diagram, Abi. So now your task is that you now go and draw the diagram again at the end of the paper, like at the end of the book. Draw this time again back. When you're done drawing it, you now extend each point down. This point, take it down. Are we there? Yes, sir. This point, I'll take it down. I'll take this one there down, and I'll take this one here down. Are we there? So I'll divide it into 2. Perhaps start from here this way. A normal graph concept. Yeah. So just take the 0 here and then 0 here, Abi. So here is concept. I'll divide it into 2. Like on that place here becomes 0 here, 0 here. So here is positive part, negative part, positive part, negative part. So the first one, this first line is for what? Shear force. Yes. Your shear force, right? Diagram. Your shear force diagram. Are we there? This one is for what? Bending moment diagram. All right. For shear force, please give me your reading. At point A, what's the value there? 20. But what's the S value in that shear force? 20, Abi. Okay. At point A is what? 20, Abi. Yes. So let me just say 20 is here. 20, Abi. Yeah. What next? At point C is what? 0, Abi. So somewhere here. True. Yes. At point D is what? Minus 20. So that will negative 20, Abi. Yeah. Let me just put somewhere here. Minus 20. Minus 20. What next again? 0, Abi. Yeah. So here. So this is the concept, please. For shear force, when it comes to point load, for shear force, I will connect them what? In a straight line. That is, I'll connect here to this point this way. I saying this one point, this one, Abi. This to this point, Abi. Observe. So here now, from this point now to where? To this point. I seen that. Hold on, this 20, negative 20, Abi. So note, yes, here's the concept. When it comes to shear force, I'll be connecting each joint with what? With a straight line. So observe that from this point now to this point, I can't join like this. This is not a straight line. So I want to meet up this line. I have to just do this way and come down this way. Are you there? Now next step is that I want to meet up this with this line. Are you there? So I'm looking at to meet up this line now. Is it that I take it this way, down this way, Abby? Observe, please. Rectangularly. So let's come to please. Look up. Instead of taking this way, there was a line here already, Abby. So I want to meet up with this. Hold on, with this minus 20, Abby. So here's the concept. I'll take it down this way, right? So this point 20, negative 20 here, right? And then this one here moved up this way. So I have this way, right? So I have this way. So perhaps this part is the negative part, right? Here's the what positive part, Abby, and then I'll do my shading this way. All right, this shading here. So you have it. This is your what? Your shear force. For bending moment there, what's the value for bending moment? What I have here? At point A is what? 0, B. So that's 0. At point C is what? 40. That's 40. At point B, 40. At point what there? That's 0. So here's the concept for shear force. Connect the straight line, B. For bending moment, connected with what? An inclined line. So just this with this inclined line this way. I think. So to get to this point, I have to just do this way, Abby. Then take it this way. Right? Should be with an inclined line. Right? So this is my what? My bending moment. So this is a positive side. Just shade this way. Alright. So this is how it works. That's it. So that's how I solve this particular question. Let's look at UDL. This is time.
Yes.
Let's look at UDL.